Now.
All right. Tonight's speaker is Stephen Fluin. Stephen is the VP of Product for HeroDevs. Stephen is a former Angular core team member and current Angular GDE. Stephen builds product and DevRel teams that solve real-world problems faced by developers and businesses and advocates for the needs of users and the community. With 25 years in the software development industry, Stephen has served as an executive technologist, consultant, and entrepreneur at Google, Trello, Chainlink Labs, and more. Stephen applies deep technical knowledge and business acumen to accelerate software development. As an avid fan of wearables and the decentralized internet, he frequently collaborates with businesses and developers in the community. Stephen, take it away.
Awesome. Thank you so much. And I'm really excited to be here. This is a relatively small group, so I will keep the chat open. So if at any time you want to yell at me, ask a question, I'm going to try and make this just a little bit interactive because I think there's a lot of different ways that I can present this content, a lot of different avenues we can go down based on the knowledge here of the group. And so if I want to really make sure that everyone here is taking ownership of this session, this time, so we can maximize it for everybody. So to kind of kick us off, the question comes up: where should we start? Has anyone heard of this AI thing? I don't know if you want to raise hands, you want to say something in the chat, but I assume people have heard of AI
Heard
at
of
this
it,
point.
Yeah, it was
but
a
I
it
think
was
it's
a
just hype.
movie. Yeah, wasn't it a movie with
Steven
with
Spielberg,
Will
right?
Smith? Yeah,
Yep,
yeah, yeah, yeah. I
yep,
remember that movie. It was cool.
yeah. What are people's go-to AI models now these days? Are we using Claude, ChatGPT? Anyone using Gemini?
Claude, Gemini for the free stuff, the easy stuff. But when I need something done, it's Claude and Claude Code.
5.4
I've heard that
mini.
before. Ooh, 5.4 minute. Anyone using open source models? I was a big fan of open source models for about a year. All right. Well, the reason that I bring this up is because if you use a LLM like Gemini, which is getting a lot of attention today, and then you look behind the scenes in terms of like what's tech is actually running under the hood here. Obviously, there's LLMs, models, a bunch of APIs, but this is an Angular application. So, like one of Google's biggest investments, one of the biggest areas where they are trying to build new experiences and iterate very quickly is using Angular as this application that manages all of people's interactions with Gemini. And I think that's really, really interesting. And it's a reflection of this broader Angular renaissance that I want to talk about today. Don't want to admit Copilot either. I love Copilot using Claude behind the scenes, like Copilot UX, Claude models. But so if you use Angular, if you use a lot of the big Google applications, you're going to notice that you are actually using Angular under the hood. And I think that that's really interesting. So uh, William gave a little bit of intro to me. So Stephen Fluin, I have been in a lot of different places at a lot of different companies now at this point. When he said 25 years, I wrote that, but hearing it out loud is kind of scary. If you want to chat with me at all, I am Stephen Fluin on basically every platform, including I've got my own little Mastodon server called Developers Live. But the reason I want to come today is really kind of share this passion in terms of what I've found works for me and what helps me be a better engineer that helps me build things faster. Because especially as we continue to grow and as we continue to evolve, the tools should stop mattering as much, but you still need to find the tools that are making your ideas and your visions manifest as fast as possible. And I think Angular is really, really well positioned for that in terms of providing a really fantastic developer experience. And that's some of what I want to go through today. So I am super excited. And I hope that by the end of this presentation, everyone is excited that things are possible that were never possible before. I had this personal philosophy of better life and work product through tooling, which is that like if we all use the right tools, our whole lives would be better. And so this idea of let's talk about a tool like Angular is really fantastic. So as a GDE, there is no content review. Google hasn't reviewed my presentation anyway, so I can speak as poorly or as positively as of them as I want. Yeah, so all of this, feel free to call me out for being a little bit of a fanboy occasionally. But let's kind of dive in. So I'm going to break this presentation into a few different sections. I want to first start talking and acknowledging some of the truths that exist out there in the ecosystem. Second, I want to talk and kind of catch everyone up, make sure that we're on the same understanding of kind of where Angular's come from and where we are today. Talk about some of the new best practices that exist out there. Talk about performance, and then I'll get into artificial intelligence and some demos if we're interested in that. So first, I want to acknowledge kind of there is an entire giant ecosystem of web development with lots of different trade-offs, lots of different approaches. And I wanted to start off kind of thinking about just today, where we are right now. And I want to understand, what are people using? So if you want to put in the chat, what are you using today for your front end stack, right? Like, I assume we're all using .NET Core, hopefully. Are we all on version 10? Are we stuck on 9, 8, 6? You can come off mute or you can put it in the chat, whatever is easiest. But and then also, like, what is people's experience with has anyone not used Angular before? Should I set up like what Angular is? Are we all coming from React?
I think most of the .NET community is going to say React, but give us the elevator pitch on Angular, because that's what really sold me.
Sure. And let's separate. So you're going to hear two terms in the Angular ecosystem. You're going to hear a term called Angular JS, which represents the original version of the web framework that was created by Mishka Hevery at Google to solve this whole, like, orchestrating applications at scale really sucks when I have to manually manipulate state across every single application, right? This was the jQuery days where we're first starting to get in and build single page applications. And I could go through the whole history if folks are interested in that. But what ended up happening was AngularJS got very, very popular, but the cracks started to show. It was very easy to shoot yourself in the foot. So back in the AngularJS days, there was a foot gun called the digest cycle. So anytime you would change anything anywhere in an application, it would trigger a digest that would run in every other part of the application. And what would happen is, as part of one of those digests, it could actually trigger another update. And so you essentially had this like infinite loop that would run until the application would stabilize, and then it would present it to the user. So this was not really a good architecture. And so the Angular team, having built and seen kind of hundreds of thousands of applications, they said, okay, what do we do? How do we fix this? And what the team decided to do at the time was to rebuild the application, the entire framework from scratch, using modern tooling. So the web had evolved too by that point, because we had things like modules. So we have like these nice imports. At the time, there was TypeScript for the first time. And so Angular was one of the first frameworks to ever adopt TypeScript. And so what they did is they said, hey, based on everything we know about how to enterprises actually scale these applications, all the things that failed in AngularJS, let's build the framework that we would want today. And unfortunately for them, that took about 2 years to do. And during that 2 years, everyone knew that the old thing was dead and the new thing wasn't ready yet. And so during that 2 years, that's actually where the rise of React came in, right? This fantastic library that was stupid simple to just render components to a screen. But then eventually, in around September 2014, they actually did release. And then effectively ever since then, or since 2016, Angular has been incrementing. It releases a new version every 6 months that I'll talk a lot about in a little bit. And it just keeps getting better. And it has this very, very strong commitment to the ecosystem of not breaking the world. So while new best practices evolve over time, we've literally had 10 years of development where the code that you wrote 10 years ago probably still works, or is very close to still working. And it's really this, I think of it not as a library like React, where you're kind of trying to render one piece. I think of it as the orchestration framework. So how do I make sure that the things that happen on my page can then be reflected back to a web backend? How can it be rendered and reflected in the top bar, right? Like when I sign in, I want the sign in to then flow into my main application, replace the login screen with other screens. And all those things end up being very, very easy with Angular in a way that maybe they're not, or you have to do it yourself in other frameworks and tools. I'm curious if someone actually said Blazor, because I have not seen real world Blazor applications. So you'll have to tell me all about that. Whereas definitely seen Angular, definitely seen Vue, Svelte, React Next, etc. So the most recent version of React was version 19.2, released in October. The most recent version of Angular is on 21. This was funnier back when they were both 19, but now Angular is way ahead of React. I say completely jokingly. Version numbers mean something. Who knows what? But The reality is, I think a lot of teams are choosing React, and actually, I see a lot of teams choosing Next. I think Vercel has done a fantastic job of building out Next to be more of this orchestration framework, although they're not doing a lot of things that Angular are doing. So I'm curious. Like a lot of people in this room said React, and they didn't say Next. One of the broader trends I'm seeing among developers is developers almost don't. A lot of the developers I talk to don't talk about React anymore. They just say we're using Next, and React has kind of disappeared as an implementation layer within Vercel, and I think, or within Next, and I think we're seeing that trend reflected in a bunch of different places. So, for example, Facebook is now pushing React out into this foundation, trying to have it be more open source and things like that. So, there's some interesting nuances here that I'm kind of curious about. And so, what I hear from most developers is like, you wouldn't choose React because you're building everything from yourselves. Whereas Next.js, you're building like a more kind of application centric thing, which, I mean, from my experience with a lot of .NET developers, this application centricity is a much healthier, more easy to grok mental model, which is very similar to Angular. Or Angular goes much, much further in terms of trying to give you the standards and practices so that large teams, so that when you have 1,000 developers, they all write code that looks and feels the same. But why has Next taken over from React? I would say developer experience is a huge part of this. User speed. So one of the things is going back to a framework where you can server-side render. I know this is back to the ASP.NET days, where instead of everything running on the client side, we have to find this now perfect balance between what is on the client side, what's on the server side, because user speed and machine crawling really does matter today. I mean, if you look at a lot of the LLMs that are crawling the web, they're not as sophisticated as Google. They're not always capable of running things like JavaScript. And so having a static version of your site is kind of more important than it's ever been here in 2026. Angular, super popular in Google and beyond. So if you're doing anything with Gemini, Google Cloud, Google Home, Google Fonts, these are all applications built entirely on Angular. And there's actually this framework within Google called Wiz. So Wiz is the tool that runs things like Google Search, Google Photos, YouTube. And it's a homegrown framework that they've been maintaining for a long, long time. But they're trying to bring, it's actually now one kind of unified team working on both Wiz across Google and Angular. And so this idea that they're learning, they're sharing, we've actually seen some of the fruits of some of those sharings already, where Google is trying to build a YouTube scale or a Google.com or Google Images or Google Photos scale capabilities into Angular, which is something that we don't always see in things like React applications. So I would say across the ecosystem, we'll look at some numbers of this a little bit later, but adoption continues to grow. It's really designed for this idea of like world scale products, or products that you can start very quickly and then continue to scale. You don't get into these foot guns that we've had in the past. And it's continuing to evolve positively, where the team has a deep caring for the ecosystem and for being part of the ecosystem, doing everything via RFC, and then evolving slowly and incrementally so that developers can keep up and kind of stay with things. Yeah, so here's a chart. So like if you just look at the growth since 2016, Angular continues to grow, and it's experienced a huge kind of explosion over the last even couple months, primarily thanks to AI. So for those of you that have heard a little bit about Angular, maybe you touched it a little while ago, what I'm going to do is I'm going to break down some of the most recent timeline in terms of like what's been coming out over the last, let's say, 3 years. Going back, we are actually early in the history. So we had that September 14th release of 2.0. So that was when Angular JS officially kind of was done. And finally, you could move to Angular, which is, you can think of it as a spiritual successor, but it was built by the same team with the same purpose, just built, I don't know, let's say 60% incompatibly, but much, much better. There was a major update to the rendering engine, a project called Ivy, which you may have heard about as of version 9. And then ever since then, every 6 months, they release a new major version. Almost all these major versions are virtually drop-in replacements, depending on the size of your application. If you have an application that is 1 million lines of TypeScript code, it's probably not a drop-in replacement for you, but the Angular team thinks about this idea of how does the breakingness affect teams? How do we keep teams moving with us? I don't know. I think actually, so part of my role at HeroDevs, the company where I lead product, is we support end-of-life open source code. And so like we actually support .NET 6 and we support .NET 8. And so I talk to a lot of teams who are stuck on the older versions. And so like a huge part of my job is understanding migration cost and migration difficulties. And then the Angular team has made it super simple to moving from one version to the next. So I'm not going to go. How many people have used Angular since version 2 or since like 2016? Because I can go through these in kind of any level of depth that's appropriate. But one of the things that they introduced that was kind of a big change where we start to see new best practices evolve across the Angular ecosystem is the introduction of signals. So signals is actually also used in a couple other JavaScript frameworks. But what it gave you was this fine-grained reactivity system. And I'll give a little demo of what a signal looks like and how it works in a little bit. But it's a primitive that's if you've ever used RxJS, it's a little bit like a behavior subject. So it's like a RxJS stream that can only have one value at a time. Oh, awesome, Jeff! You started using it in the last 6 to 12 months for new development. That's fantastic. In 2016, the team also started working on hydration. So historically, when you had any sort of server-side rendering combined with client-side rendering, when you wanted to do actually load the application, you would just destroy everything that the server rendered and replace it with client-side rendered code. But they started working into a world where you could actually hydrate that, and then instead of destroying everything, you could just continue on. And I'll ignore some of the minor features here based on the crowd we're hearing. They built a completely new control flow. So if you were used Angular, I don't know, 4 or 5 years ago, you would see like ngIf, ng4. This was very similar to AngularJS. And they've replaced that all now with a more readable syntax, where you just say if for switch with this @ sign as the kind of control indicator. And you can use like brackets instead of HTML tags that are kind of faked into this kind of conditional and control flow logic. We also introduced the idea of deferrable views, which I'll talk a lot about more. And then the build system just keeps getting faster and faster. I don't know if anyone here cares about build speed, but Angular applications now, especially with hot module reloading, can rebuild very, very quickly. One of the problems that the Angular team tried to solve back in 2016 was this idea of how do we know when something in the universe has changed? And so what they did originally was they created this thing called Zones.js, where it monkey patched across your entire browser any asynchronous event. So promises, XHR requests, all these sorts of things. And they would have any asynchronous event trigger a change detection cycle. Now, in Angular, it was only a single directed graph of change detection following the component model. But this was something that was still a little bit weird, because now if we use modern JavaScript, we have things like async await, which aren't monkey patchable because these are our asynchronous primitives in the browser now. There's no way to monkey patch that. You can't modify the function of async await like you can promises. And so the Angular team introduced zoneless change detection back in 2024 so that you could now start to build applications where you're not monkey patching any of that, and then you take direct control of when the application changes.
Steven,
yeah.
can you give us the 101 on monkey patching? I've heard that term
Sure.
kicked around on the front end side of things, but I'm not familiar with it.
Sure. So monkey patching is the idea that in JavaScript you can really modify anything. So I don't know, let's just go into here. So this is a Google application, right? So I'm sure it's got Google Analytics installed. Let's check. Or GTag. Let's find a property that exists. Document. So document is a thing that's coming from the browser or any of these methods, right? Like toolbar API. I can go in and I can modify any of these things. So I could, if I wanted to, I can scroll to the bottom here. I could take toolbar API and redefine any part of it. So as a JavaScript developer, I can take any code that exists in the DOM, exists in the JavaScript scope, and change it and monkey patch it. So I could say like, hey, toolbar API equals now, it's a new function that's going to console.log and then call toolbar API. Right? I could maybe say x equals toolbar API.
And none of the existing toolbar API is there anymore? You've just overwritten it?
Well, I saved it as x, right? And now I'll just invoke x. So there, I just monkey patch toolbar API. Now, so when anyone calls toolbar API across any of the application, they'll first, I'll say like they will console log. Oh, I meant to console log the function. I didn't take any parameters. This will definitely break my browser. If anyone invokes this, if any application breaks this code, I didn't monkey patch it correctly, but yeah, effectively everything in JavaScript, almost everything is mutable, right? Like is not a number. What is it? I guess that's a function within the scope. But like anytime there's a function, you can rewrite it. You can overwrite it. There's not really a protected landscape.
Okay.
So monkey patching is doing something like this, where you take an existing JavaScript function that exists in the browser, and then you redefine it to do something else. And so what the Angular team did was they patched promises, and they patched XHR requests and all these things, so that automatically when those things, when a set timeout finished, it would automatically trigger to change detection. So the developers didn't accidentally make a mistake there. Yeah, great question. And we started getting into some code, which is probably a little bit clearer and more fun. So since May of 2025, I've been working on more advanced resumability, which I'll give a little demo of. And then in the most recent release, we're zoneless by default, so we don't monkey patch at all. We now have these kind of lower level reactive primitives that manage, that tell the application when the universe is changing. And again, if you think back to what I said about this commitment to developer experience, not breaking things quickly, you can still use Zone.js. You can still rely on it. It still works. And it's the zoneless version has been available for months and months and months. So even though these things are changing, your code is in general going to keep working, or at least you're going to have 2-3 years to adopt a new capability or a new change. So if you don't know Angular, some of these won't make sense, but I can demo all of these. But we got rid of the requirement for modules. So ng modules was a thing that was invented at the very beginning of Angular to help organize code. We don't need that anymore. You can just create components that are standalone, and you can import them anywhere you want. We have a new control flow syntax that allows you to kind of loop through things. And then we have this idea of signals, and now signal forms, and server-side rendering Angular applications is now like stupid simple. And I'll give a little demo of that. So where do we want to go from here? So what I'm going to do is I'm going to walk through a couple. Would it be helpful if I just showed off some Angular code for a little bit?
Yes, sir.
Before we get into that? Okay, let's just do that. Here we have a Angular application. So let's start talking about how do we want to do this best. Here, I'm going to make. No, that this application is relatively simple. Okay, so an Angular application just out of the box is going to have. Actually, let me just demo that real quick. So what we'll do is we'll go here. I'm just going to create a new Angular application. So Angular applications are pretty easy to create now. npx Angular CLI, new. What do you want to call our app? Hi tc.net. And I can say dash minimal. So it's going to ask me a few questions when you create an Angular application. It's going to say, what sort of style system do you want? Do you want to just use bare CSS? Do you want to use Sass? Do you want to use Tailwind? So I'll just use Sass. Do I want server-side rendering? I'm just going to say no for this simple, to keep it simple. And here we have the most basic Angular application that you can. So we've got a prettier config, a README, a get ignore, a JSON file that tells us how our Angular application is going to build, some TypeScript configurations, VS Code. Like these are all helper. Like none of these are actually part of the application. We've got a main TS and an app.ts. So if we code our hi tc.net, we should see all those files that I just talked about. So you've got a main that bootstraps your application, and we'll bootstrap it via the config that you have, which is basically just saying, it's using the router, and the router is going to just default. It's your application is going to boot with hello, whatever the title of your application is, and then it's got a router outlet. And so if I npm run start here, should load on port 4201, hopefully. Nope, that fun port. All right. Hi, tc.net. So when in an Angular application, I can just create components relatively simply. So I can just say npx ngg. So that's generate. So that it will kind of code create, like maybe we want to create a home component. So G generate C component. It'll just create a home component. It'll say home works. Then we could just take our homepage of our application here and we could just add it to the template. So we could say app home. Tooling should automatically pull it into our imports so that it knows what that component is. And we got homeworks. All this component, you can pass in data. So I could say like, hey, home takes an input, it takes a parameter, whatever. But yeah, this is these building blocks of component-based architecture. Sorry, I just realized it's really small. Are what let you build an Angular application. And then, so like if you wanted to create a counter here, I could just say const counter. Let's not make it a const. All right, so now we can just render the counter. So you can kind of mix HTML and variables here. The counter is at. Great, thanks, Copilot. So we got a counter, and then we've got a button that whenever you click it, should increment the counter. So pretty simple. And then you could write code of the format at if counter is greater than 5. You could just say, whoa, that's a lot of clicks. Does that make any sense? So it's you've got a template language that determines what gets rendered to the screen, and this template language is extremely efficient because it gets rendered actually not into a complete like let's re-render everything. Things that don't change have no render function. There's a render function that like every time counter is executed that runs, but it only checks the conditional parts. It only checks the variables, and so it knows where this node is, and it will just update that node. It won't re-render hello. It won't re-render title, and so Angular ends up being very, very efficient. Any questions on that? I mean, if you haven't seen Angular, it's pretty great. So Jeff, does this match your understanding? Sounds like you started using it 6-12 months ago. And just to reiterate one of the things I said earlier, which is that Angular is heavily optimized for large teams to collaborate because it gives you a bunch of standards. Okay, how do we handle routing? So like when the URL bar changes, when I move across my application, how do we pass state between it? How do we pass like that user intent? That's very clear. State is very clear, like what it belongs to, where it exists. The reactivity primitives now enforce you to always know where changes are coming from, and then we only update the parts of the application where that change is being used.
Are there
so
something like, like hooks, like in React, like use state or things like that in Angular, or not so much?
So you almost don't need them. So like use state, like you need to use state in order to achieve what I just said. So like you've got this in Angular, you have a strongly object-oriented component model. So this component has state here. And then whenever that state changes, it will reflect here. So the other thing you could do now is you've got this reactive primitive. So like by default, an Angular application will actually, if we let's say, let's create a function here. So let's create a skip to 10 and say this dot counter equals 10. So we'll automatically add that button here. So I can skip to 10 directly. So in React, you might want to make that a hook because if this change comes from outside of the component, you might want to do something about that. The way that is now handled is via this idea of a signal. So we can say this dot title. So what we do is now we have these signals. So it's basically a variable that has a set method. It has an update method. It's got a few different methods on it. What will happen is Angular can watch and understand these signals, how they're being used across the application, and then it can inform change detection directly via that. So skip to 10 hits 10 here, but we're also seeing this invocation of that here, where we're invoking the title to check its value.
That's cool.
Yeah. So like, I will say, doing things with React, I've always found to be hard. Like I've written a lot of React code at this point, but you can do things in Angular that like much simpler than you can in React. So like, let me see if I can give a quick example. So I'm going to create a directive called A. So we've got our A directive here. And I'm just going to change the selector to A. I forget if it's this or this, but we'll check it. So what we can do is we can console.log A constructed. And then I could do something like attach. So imagine every A tag in my entire application, I wanted to automatically apply no follow, no refer, right? So what I could do is I could get access to this native element. Here, let's just have Copilot help us. The native element and set no follow, no opener. This is not the right way. Let's see. Sorry, we're going off on a big tangent here, but like, I could create a class that then automatically applies to every A tag that exists in the application. So if we ever came up here and we said ahref equals I can automatically kind of improve this native element without ever having to do like another line of code. And it will force all of the A tags in my entire application to follow that. So if we look here, we should see. No, it's not working. Sorry, I wasn't prepared to talk about this right now. But yeah, so like React has hooks. It's a much more object-oriented model where because the renderer is entirely hooked up automatically via the template, and very predictably, you can just manage the state of your component.
I see why .NET shops use this because it feels very .NET.
Yeah, it looks and feels like .NET or Java. Like it looks like a big application, not a mess of JavaScript. Right. And so like every component can have a super simple API where you can have inputs and outputs. All right, I'm going to get back to my presentation here. We can come back and talk more Angular nuances in a little bit. So, okay, let me ask. So for anyone in the chat, is this way too deep or is it way too basic on Angular? Or is this way too advanced on Angular? Because I want to make sure I'm representing all the voices here.
Anyone? I'm with you, but with a little hat tip to front-end masters.
Okay. All right. So this level is good. So I'm going to keep it roughly at this level. And so one of the things that is really hard in web performance is performance. And so if you build a naive application in React, you're going to ship just a giant bundle of JavaScript, right? Is that everyone aware of that? So like your entire JavaScript application is going to end up being shipped down at the beginning. You first load the application and all of the JavaScript that could ever be needed is going to be shipped to the user. Angular makes it really easy to not do that. And so we've got this like router outlet here. So that's actually like, you can think of this as like maybe our header. So if we were to scaffold this out like a real closer to a real application, maybe this is all our header. And then you want this page contents to change based on what page you're on. So what I can do is I can say router outlet, and then I can say go into our routes and say, hey, when the user's on the blank URL, we're going to render the home link. So we're on the home screen now, and then maybe we want to create an about page. So I'll just say we'll create an about component, and then I'll wire it up so that when you go to path about, load component. All right. So what we should see here now, we got to create some links. We got to create a little navigation section. What is it, nav? Is there a navigation section natively? No, whatever. Okay, doesn't actually matter. So now we have home and we have about. Those are not showing up as properly. Let me just check one thing. All right, I have a bug here. Oh, I probably don't have a router link. All right, so when you're on the home screen, so no blank URL path, we're on the get the home component. When you're on /about, you get about. Now, what I did here is in the router, I used this keyword called load component. And so what this is actually a lazy boundary to the rest of my application. And so all of the code for my home component and anything that it depends on will come in as a separate bundle. And so if we take a look here at our build, we should see a bunch of different, so it's creating chunks for those components. So our about component is going to pull in about 1.6 KB of code. You can imagine that like you've built some big mapping thing or customer engagement form, like maybe you've written 10 megabytes of code. You don't have to load that 10 megabytes of code until the user actually hits that component. So we'll see if we clear here and we hit home. Let's just refresh. Let's run the server. It keeps changing ports because I've got another demo in the background. So we're on the home screen and we don't actually load the next chunk until the user hits about. Now we load all the code for about. And so you have this kind of built-in capability to load only the code you need exactly when you need it, which then means that your home route, your basic, like the source, the HTML code here is like, I don't know, AKB. it's probably very, very small. I mean, we've got some debug mode going on, but we've got 0.6 KB of HTML. Our client code is 0.2 KB. Like these are very, very small, and we can load exactly the code we need. Behind the scenes, Angular is loading a bunch of other stuff, but we're at 2.5 KB transferred. If we disable the cache, we're at 1.8 meg, but we've got all this debug code and live reload and all that. So like you can kind of ignore that chunk. So this is really, really a fast framework, which is something that Google likes. If you want your content crawled, if you want your content indexed, building fast web applications is becoming more important. And even if you're just building an internal productivity app for your employees, they care. They care about how fast it loads. And this kind of instant feeling, when you can start delivering that to everyone, it delights and amazes, and they will love you for it. All right, yeah. So before we had this module organization, but now we don't even need that. We can go directly to components as we need. And you have to be, you're just explicit, you pull in whatever you want. And then if it hasn't been seen before, the build system will chunk it out into separate JavaScript files. We talked about signals. So signals are basically a way to have reactivity across an entire application, not just at the component level. So you saw how component, when I clicked, it would update itself. But that's not efficient if every component has to check all the state across the entire application. That was kind of the AngularJS world that we lived in 10 years ago. We get exact precision of, hey, if I change a signal, that signal can be handed around anywhere, and only the people that use it will be notified. And it's a very, very small dependency. And it's actually a standard now. It's actually used by a couple other frameworks. I think Svelte uses it, or one of those. So here's an example of a counter. You say signal, initialize it with 0. You can ask it to update. You could double it. You can create any function you want, and then you just use it in a template, and it renders. And then because you're storing your entire model, the kind of state of your application as signals, it informs exactly, you can have a perfect view of what parts of the application need to rerun. And because Angular, the way that the templating works is like the Angular component after render or after compilation knows exactly where in the DOM that value is being represented and what's affected by it, it only re-renders exactly the pieces that need to be. And so that could be just in the parent component, and it could be leaving a child component entirely alone. And so signals are now used for inputs, outputs. So I talked about this idea that components can communicate with each other. So a component can emit a value. Like imagine you build a form component, and that component emits when, hey, I'm done. Go to the success screen, or when there's an error. Hey, there's an error. Do something with this error. Or they can take inputs. So I, for example, have used inputs for, like, imagine you have a ratings bar. So you've got a product list, and every product on that has a repeating component of a ratings bar, and it takes in the current value of that rating for that product. And then you can use signals to fetch data from the internet now. So we've got this idea of like a resource. So a resource is just a special kind of signal where it has kind of a loader, so you can get this, like, all the status of that signal. So you can say, does it have a value? Is it loading? Can I force it to reload? All those sorts of things. And you can get very, very smart around how you're using that signal versus just having one value at a time. And we talked about template control flow. So you've got this if else, switch, all the sort of normal things, for loops. You can also do build declarations. So this is one thing that I use. I love having information about my build actually baked into the client-side web application. So for example, in a lot of my applications, I will define this global variable called version that then is available within my JavaScript application. So I can, like, render that to the screen so the users can see, oh, the build of this application is this SHA, and it's coming directly from Git, which is kind of cool. So I've talked a little about performance, but this is something the Angular team keeps, because they're building applications at Google where performance matters a ton. They keep making it better. And so we have this idea of server-side rendering now, in pre-rendering, where you can either server-side render, which means to generate the HTML for the user on the server at request time, or you can pre-render, which is to, like, at build time, render all the HTML so that it exists in kind of this perfect state. And then you combine that with hydration, where imagine if we have the entire application pre-rendered, we still want it to be able to be mutable, but we don't want to have to re-render everything. And so hydration now does that. So if we go back to our little mini example here, I'm going to try something. So I'm going to do npx ng add at angular/ssr. So what this should do is this should turn our client-side application into a server-side rendered application. So, and all we have to do is say pre-render. So it's going to default to pre-render. And so now when we restart the server, wherever my server might be, here, let's do -- port equals 4201, so we don't have to keep reconnecting. Is it not -- port? All right, I have forgotten the port flag, so we will just deal with this issue. I apologize. Yeah, Angular is super good at helping you build better applications. So for example, it has noticed that now we are importing home into where we're pulling in that code, but we don't actually use it. And so we know that it's safe to just remove that. So we're both getting that inline, like, IntelliSense that code is not needed, as well as error or warnings at build time. It's fine to include that code if you need it, but, like, it detects that we don't need it and just automatically removes it. So, all right, now when we take a look at our application on the right port, what we'll notice is when I hit Control U and I actually view source, instead of the application just being this, like, app root, completely blank, we're actually getting all of the code rendered by the server. So an LLM could parse this, Twitter can parse this, all these sorts of things, where you get all the HTML out without rendering any JavaScript, and then it's actually hydrating behind the scenes. So when I click increment, it just works, right? We don't have to re-render anything. We're not recreating the DOM, so that there's no largest contentful paint punishment. And you get the best of both worlds, where the static HTML just works, and you get the rich, engaging experience that you're trying to build for your users. Any questions on that before I move on? And just looking at the time, I've been taking a lot of detours. I apologize, but we're getting into the demos early, which is great. So lazy loading is hard. So I talked about this idea that you can do it at the routing layer, but Angular is actually making it much, much easier because there's a lot of weird cases. Like imagine that you have a loading. So like let's say you're loading some JSON data, right? You've got a meg database that you're now downloading and you want to parse and render that as a list. Like maybe it's a product list. You've got loading status. You want to show error states. And then so like you can imagine we've got this list of recommended movies. I can actually defer that. So now this is a new feature where instead of rendering that right away, I can wait until the user actually engages with it. So and then I can add a loading state, so automatically show loading until it's available. I can add an error state if that JSON fails to load. I can automatically show something. I can defer it until it's actually in the viewport. So imagine that we've got this cool, rich, like I don't know, feedback form at the bottom of every movie review. You could defer that until it's actually in the port, and then you can choose to lazy load that or just wait to hydrate and render that. So don't load the JavaScript code until the user needs it. And so this is how you build like really, really fast, amazing applications. So like a lot of placeholders there. You have built in, like you can wait until the browser is idle. You can wait till there's like you can do it after 10 seconds. You can wait till it's in the user. You can wait till the user clicks on the page. All sorts of things you can do. What else do I want to do? So yeah, so if you do think about diving into Angular with the server-side rendering piece, effectively you get out just a runnable JavaScript file. So server.mjs is a Node.js application that you can just run in Azure. You can run it in Cloud Run. You can run it in AWS, Lambda, whatever you want to. And it handles the entire serving of the application. And it handles it based on how you chose to do this. So there's tons of great new primitives in Angular, and all of them are super easy to adopt. So the Angular team, because they have to maintain hundreds of thousands of code bases across Google, they've actually built just automations that, hey, if you want to switch to any of the new best practices, just run this command and it'll automatically switch over all your code to the new best practice. So we're also coding in an LLM era. So like a lot of teams are now trying to vibe code. And the Angular team saw that repeatedly LLMs were choosing React. And they're like, well, why is that? Is there just more React code on the internet? Is React better in some way? And after researching it, what they found was most of the product teams, so like Codex, Firebase Studio, whoever, they were hard coding in a prompt that said, use React and here's the architecture you should use. And so they built a tool to actually independently measure how well an LLM handles a framework. And what they found out is Angular actually performs among the best. Like React is way far down. Like LLMs scaffold and maintain very poor React code, whereas Angular, because it comes with all this structure, because it comes with this philosophy behind it, it's very easy for LLMs to understand and scale, and they don't make a lot of mistakes. So Angular is kind of now being designed and improved for that universe. So there's an MCP server that you can include that will automatically teach your LLM how to write better code, and so it's Angular just keeps getting kind of better and better for this type of problem. So Angular, if you haven't seen it, it's easier than ever. It's getting better and better. It's not stagnant. Adoption is growing. Usage is growing. Enterprises, lots and lots of them love it. And the future is really bright for developers. So thank you so much, everyone. I have a feedback link here, as well as happy to dive into any more code or conversations that would be valuable.
Outstanding. Thank you. Imagine me times 100. Lots of applause. There are people, there's like 20 people at Jared's place, so lots of applause. So yeah, there we go. There's the one clap representing the 20 people watching from Jared's. So that's great. All right, cool, excellent. Does anyone have questions? You guys have been asking right along. Questions for Stephen? Any other questions? Angular. Anything? All right, great. Well, in that case, I'm going to stop the recording so we can give away a prize. And then if someone comes up with questions in the meantime, that's cool too.